Hello everyone, welcome back. In a series of lecture, till now we have covered the file node in IBM ACE. Now let's start with the routing node in IBM ACE. When talking about the routing node, we have the filter node, we have the flow order node, we have the level node, route to level, route node, pass through node, and sequence node and the resequence node. So these are the 8 nodes that is found under the routing template. Out of 8 nodes, few of them are not much of importance, not frequently used. So I will try to cover as much as node that are quite important and frequently used. Okay, and later if you are requesting to cover the node that I left also, then I will add later the thing. Okay, so well, let's create the application directly on the toolkit. So let's go to toolkit and just click on new application. Just give any names, routing. Okay, and just click on next. Let me select the library for error handling also. Just click on finish. Further, let me create application message flow also. Suppose message flow, my name is, sorry, routing message flow. Okay, so I created a message flow, and if you see, you know that we have the two segment. First is the toolbox and second is the connector. So till now we have covered the two connectors. One is the file related connectors, that is the file input, file output, file read, file exit, file editor. And before that we have seen the MQ related connector, like that the MQ input, MQ output, MQ get, reply, header, publication. Okay, in this lecture we are going to cover the one of the important toolbox segment. If we go to the toolbox segment, we have a routing template. Okay, and if you expand this, you will see total 8 nodes are present. We have the filter node, we have the level node, we have the route to level, we have route, we have the flow order, we have the resequence, we have the sequence, and we have the pass through. Let's, before starting the each one one by one template, let's start with the basic definitions of each one of them. So when talking about the filter node routes a message according to the message content by evaluating the ESQL filter expression. So when talking about the filter node basically filters the message according to the ESQL logic what we have written under it, and according to that it sends the message into different terminal. It sends the message into the, let me just quickly drag and drop it also. So according to that, it basically takes the message, and according to whatever the ESQL logic you have written here, according to that it propagates the message according to the failure, unknown, and false terminal and true terminal. Okay, so that's the filter node. When talking about the route node basically help us to route the message according to the X path that we have mentioned under the filter table. Okay, so if you talking about the route node directs the message down various path by evaluating the X path filter expression. So whatever the X path you have written here, according to that it basically filters the message and send to the different downstream system. Okay, further we have the level node and the route to level. Level node and route to level are used together. Route to level is used to uh, what I say that is used to route the masses to different levels. Okay, you can say that. So suppose we have a route to level here and we have the level here. So with the help of this route to level, we can navigate the masses to this level. Okay, so with the help of route to level, we can navigate the message to different level according to level what we have set. Okay, so if I go to definition, the level nodes provides a target for the routing decision. That's correct. And the route to level interrogates the message to determines the identifier of level node which message to be routed. Okay, that's the same thing it is saying. So route to level basically decides according to the level that we have set under the local environment where message need to be routed. Okay, and if you go to definition also, what if we use the level node, in a combination with the route to level node to determine dynamically uh, the route that a message takes through the message flow based on the content. Okay, same thing it is saying. A route to level node is a combination with one of the more level to determines the route that a message take through the message based on content. Same thing it is saying. So you can understand in basic that route to level is used to route the message to different level based on the level property that we have set under the local environment, and same whatever we set under the level, this level here. Okay, further we have the flow order. Flow order is used to send a message into order. Okay, so if you see the flow order, we have the failure terminal, first terminal and second terminal. So whatever the input message came, it will first go through the first terminal, and again it will return back to the flow order, again it will move to forward to the second terminal. Okay, so that's is called the flow order. So flow order force a prescribed order of processing the message that this node propagates. The same thing it is saying. So flow order basically help us to follow the message in a prescribed order. First it will go to first and then it will go to second. Further we have the sequence node and the resequence node. Sequence nodes basically insert a sequence number into a message. You know that the few of the business, sequence of the message is quite important. Suppose there is source system who is sending a message and they want their message to be follow in a sequence. Okay, so we can use the sequence node to send a message into a sequence, and further we can use a resequence node to reorder the message into a sequence. Okay, so in case what happens, suppose I have used here a sequence node and I have add a sequence number to a message, and later to make sure that the message is going in sequence, we can add the resequence node. Resequence node basically checks whether a message is in sequence or not. Okay, so same thing if you see here, sequence node add a sequence number to one or more group of input message, and resequence node controls the sequence in which a group of incoming message are provided message flow. Okay, so with the help of sequence node we can add a sequence number to a message. With the help of resequence node we can basically check whether a message is following a sequence or not. Okay, so that's all about the brief of all the nodes that we are going to cover into the this lecture. Okay, so I will try to cover the filter, level node, route to level, route node, flow order, and the pass through. Pass through is used to enable the versioning of a subflow at runtime. So with the help of pass through we can provide some levels, and that level basically we can, with the help of that level we can identify the which version of subflow we are included into the main message flow. Okay, okay, that's all the brief of all node. Okay, now let's start with the filter node. Let me first delete these all. So when talking about the filter, that already told you it is used to filter a message according to the logic what we have written here. Okay, so let me use the first MQ input here. to send a input message to this filter node, and let me use the 2MQ output to send a message to different destinations. Or let me use one more output for unknown terminal, and let me use the error handling for the in case of any failure happening. Okay, now that's all. So now let me connect the terminals. So let me connect the true with MQ output, false with MQ output 1, and unknown with MQ output 2, and the failure with the error handling, and further this failure and catch with the error handling. Okay, and let me modify this one for now, and let me connect this directly here. Okay, let me add a breakpoint. So I have designed a flow, simple flow, where I am taking a input message with the help of MQ input node. With the help of filter node, I am filtering the node based on the logic whatever we are going to write under the filter. According to logic, I am sending a message to true, false, or unknown terminal. In case of failure happen, I will be navigating through the failure terminal. Okay. Before that, let's understand what are the logic we are going to return. Let's understand the situation, what situation we are thinking. Okay. Let's suppose in the this is the example you know very well. I am going to use into this tutorial. Okay. So we have the order details. Under order details, we have the orders. Under that, we have the customer name, quantity, total price, delivery address, and mobile number. And if you see, we have a total price here. We can set some value. Okay. Now let's assume a situation. We want to filter the message according to the price. Suppose I want to segregate the thing. The person who has order less than $2,000, they will be moving to some other place. Or let me just have written some situation somewhere. Let me just see. Yeah. So the person who has ordered with greater than 2,000, they will navigating through the two terminal, and the person who has order less than 2,000, that will be navigating through the false terminal. If any case apart from this, any two case will happen, it will follow through the non terminal, and in case of failure happen, it will going to move through failure terminal. Okay, so situation is like that. Okay, so if greater than 2,000 order total amount, then it will be a true terminal. So let me just also first let me add the queue name to all. So let me give here queue name as a test dot in, and let me give the queue name here as a output queue as a test one dot out, test 2 dot out, and let me give here as a test 3 dot out. Okay, and so I have given the queue name. So in case of it will navigate through the true terminal, so it will go to the test 1 dot out. In case of it will be navigate through the false terminal, it will go through the test2.out, or in case of it navigate through the unknown terminal, it will go to test3.out. So better understanding, let me add here something like that. MQ output, it will be sub condition like greater than 2000. So it will be looking if the total amount is greater than 2000. So let me just add here also. Maybe if the total price is going to be greater than 2000, and if the total price will be less than 2000, then it will move through this terminal. And in case of unknown something situation happen, okay, then it will follow through this segment. Okay, now let's add the condition here. So here I am going to add the condition to check it. Okay, so let's declare so what I am going to check, I am going to check this total price. If the total price will be less than 2000, then it will follow through false terminal. If it will be greater than 2000, it will follow through the true terminal, and anything else case it will happen, then it will follow through the unknown terminal. So we are basically filtering the message based on the condition. Before understanding the filter node, if you just click on this, if you see, we have the data source segment, we have the transaction, we have the filter expression, but we are not seeing here the compute mode. If you go to template, and if you just open any drag down, if you any drop down the compute node, you see under the compute node we have a option called compute mode. What here in the filter node we don't have a option of compute mode. And if you remember, if you recall the class when we are learning the ODBC connectivity, we have understand a situation where we have learned the database node. We have learned the where is the thing, just 1 minute. We have learned this database node, and in database node it was also no compute node was there. Similar property we have into the filter node. So in filter node we don't have the compute mode option. So that's the reason there will be a no input route here, there will be a no output route here, there will be a no local environment here, and we cannot do any type of transformation with the help of filter node. Whatever the incoming message will come, we will only just send to the different destination according to the filtering logic. So we can apply some filtering logic. According to that, we can navigate the message to the different downstream according to the logic what we have written. Okay, okay. So you know that to access the message, if there will be no facility of input route, and if there will be no facility of output route, and to access the message from the input route, instead of input route we have an option called route. So we can access the input message with the help of root.xml and see if it is XML message. Okay, so let's write some code. I think I have already written somewhere previously, so let me just copy it. It will be easy for me. You can see this is a simple code I have written. You can, I will be explaining you, don't worry. Okay, this is almost, if you want to you can do, but otherwise it is not required. What I am doing here, let's remove this thing, although it is not required. Why I am doing this? Just 1 minute. Let me make a proper alignment so it will be look good. Okay. Now that's all, and here let me make the return false. Okay. Now let's understand the code. Here I am declaring a reference variable inref to the orders. So I am writing declare inref reference to root.xmlnsc.order So my inref is directly referring to this order. So with the help of inref.customer name, we can fetch the customer name. With the help of inref.quantity, we can fetch this. We can ref of with the help of inref the total price, we can fetch the this total price. Okay. Similarly, we can fetch the delivery address, mobile number. Okay. So here, if you see, instead of out input root, I am using the root. So if there is no compute mode available under the node, so in case instead of using the input root, you can use the root to access the input message. Okay. So my inref is directly pointing to orders. So with the help of inref dot total price, we can access this amount. So I have simple written the code that if else condition. I am checking if the inref dot total price is greater than 2000, then I am returning true. You can see if the total price is greater than 2000, I am returning true. Okay. If else if the total price is less than 2000, then, or you can apply, let me do one more condition, less than 2000 and equal to 2000. Okay, that will be more good. Okay, so if it is greater than 2000, return true. Less than equal to 2000, okay, that will be return false. And apart from that, any case will happen, it will return unknown. So it is condition is like that: if the total price is greater than 2000, it will return true, and it will follow through the mq output. This it will follow through the this queue test one out. Else if the total price is less than or equal to 2000, then it will move through the false terminal, and it will follow to the queue test to the out. And if any other case will happen, it will follow through the unknown terminal, and will move to the queue test 3 dot out. Or in case of some failure happen, like that database issue or some other issue, then it will follow through the failure terminal. Okay. Now we cannot add only one node right here. If you have some more options, suppose you want to perform your database operation with some compute node, and you want some other nodes like that, you can add as many as node here. There will be no restriction. Okay. So it is not just it. I'm just showing you a small example, but if you want, you can try with some more example. So here you can try with some more nodes. Even if you want, you can add some subflow here. Okay. So that will be, because in real industry it is not a small flow like that you are seeing. Okay, it is a very vast complex. Mostly I have seen the filter node, we are using a situation like that. Suppose I am using here one subflow, I am using here another subflow, I am using here another subflow. Okay, so these three subflow, ideally if I will add into this main flow, it will look some lengthy and not good. Okay, so to make the flow good looking and simple, what we can do, I can add directly subflow which having the many nodes. Okay, similarly I can add another subflow which have many nodes. Even if you don't want to add a subflow, you can add like that. I can add here compute node, another compute node, another compute node, another file node, output node, simple like that. Okay, you can add the things. Okay, so once the message will come, it will come here and it will process all the step for the this. Okay, now, but for now I am showing you simple message. I just want to put the message to this queue. Okay, so that's the simple logic I have written here. Okay, it's time to test the flow. Okay, and let me tell you one more point. If in case what will happen, I have written a situation like that, return true. Okay, so in case of this situation will satisfy, it will return to the true terminal. Okay, but suppose this is terminal is not connected, then what will happen? If this terminal is not connected, in that situation my message is going to lost. So if the terminal is unwired, my message is going to lost. Okay, now let's test the flow. Okay, before testing the flow, let me clear the queues if any other earlier message is there. Okay, so test2 dot out, there is no message. Let me check the test1 dot out. Okay, there is 7 message. Let me clear the queue and let me check the test3 dot out. Test3 dot out, and let me check if earlier message there. Okay, there is 8 message. Let me clear the message. Okay, now it is clear. Now let's hit the flow. Before hitting the flow, let me build and save the bar file, and build and save the bar file. Let me select the application that I have created. My application is the routing this. Okay, just 1 minute. Routing application, just click on build and save, and my application has been built, bar file has been built. But if you remember, few minutes back I just modified the error handling, because earlier I have used some pass through node. Okay, that I don't want now. Okay, so I modified the error handling, and this error handling is I am using is a static library. You can see also, if I will check this, you can see I am referring a library. I am referring a library, shared library. Okay, and if you do any modification to library, you need to redeploy it. So let me first redeploy the library to make the change in effect, and let me redeploy the application. Let me deploy the application. Application deployed successfully, and we have the debugger already launched. Now let's test the flow. Let me send a message first which is less than 2000, so it will let me 1500. So this person who has ordered for the total price is 1500. Okay, so first case I am taking where the total price is less than 2000. So let's me take the message and hit the flow. So this is the message I have taken, which is less than 2000, and let me hit the flow. Flow executed, and okay, not sure what is happening. Let me check it. Let me complete the flow, and let me do one thing. Might be my debugger is launched from the long time, so that's the creating an unwanted behavior. So let me relaunch it. Okay, so I have relaunched the debugger, but before that, let me see if anything I am lefting. In basic I have saved the queue name. let me select the message domain as XML NSE so that I can send only XML message. Parsing option, let me select as a complete in case of any parsing error happening, I can see. And let me see everything is okay. In filter node, that seems looking good. In coding wise, I am declaring the and ref, I am checking the conditions, I'm returning, I am doing return false because already I am doing here return true and return false. I'm navigating through the terminal, so there is no requirement of, if you will not mention here, it will again move second time with the blank message, so that's not, I don't want to achieve it. Okay, further in the queue, I have set the queue correctly, correct. So it seems to be looking good. Let me add more breakpoint for the failure terminals. Okay, now let me build and save the bar file and deploy it. Now let me take the message and hit the flow executed. You can see now it is going through the out terminal, and you can see the same message. We have the explanation order details. Under that orders, we have the total prices of 1500. Go inside the compute node. With the help of IronRef, I declared a reference variable, and you can see under the IronRef we have the these all four field: customer name, quantity, total price, delivery, address, and mobile number. These are 5 field. Okay, and with the help of IronRef dot total price, we can access this value. So if you see, if we have the, I am checking if the total price is less than greater than 2000, so this condition is false, so it will not, if this if block is not going to execute. Further it will check the else condition, whether if the total price is less than equal to 2000. Oh, okay, this condition is true, so this block is going to, else block is going to execute, and it will return false. And return false, it will directly come, you can see it directly came to return false, you can see. And through the return false, it will move through the this terminal. Okay, return false, it will move through the this terminal. So you can see through return false, it moved through the this terminal, and message will be written to the this queue. You can see that this is the queue for the price less than 2000, right? So you can see message written to this queue, and if I will browse the queue, you can see it is the test2.out. You can see the same message, right? You can see the same message. Similarly, if you want to try some other condition, suppose I want the condition where price is greater than 2000, suppose it will be a $2500. Okay, so if it is the price is $2500, in that case, let me take the message and let me hit the flow, and you can see this time it came here. For that, we got inside the compute node, it checked, it will declare the INREF. For it will check if the total price is greater than 2000. Yes, the price is greater than 2000, so it will if block will going to execute, and it will go to the return true. And further, with the help of return true, you can see it is moving out from the return true, and it will be returned to this queue. Okay, so you can see, and if I will browse the queue, you can see the same message. If this queue is the test1.out, right? So test1.out, and if I will browse the queue, you can see the same message. Suppose this is the condition where we are checking the return true and return false. Suppose take a situation where somehow the total price field is coming as a null. So total price field is not coming. In that case, it is hard to define whether the price is greater than 2000 or less than 2000, right? In that case, it will be, you can see this time the total price field is not coming. In other words, you can say that the total price field is null. So in that case, it will be not easy to compare the total price, right? So this condition will be also false, this condition will be also false, so it will directly return through return unknown terminal. Okay, you can see this time it will came to return unknown, and it will follow through the unknown terminal. Okay, and it will, if you see, it is going to write through the test3 dot out. If you check the test3 dot out, there is already one message. Let me just browse the latest message. You can see the message has written to test3 dot out, this message. Okay, this is the latest message. Okay, now let's take a situation where I am sending the total price, but I am not sending any some integer type of integer. I am sending something like that, some alphabet. Okay, so it will be also not easy to analyze the thing, right? So in that case, if you will send a message like that, or if in case of doing something other thing wrong, so it, in that case, it will follow through the failure terminals. Okay, so this time I sent a total price, but if you see total price is something 250 something alphabet, so it is a alpha numeric value. Okay, so it is also not easy to compare, right? You can see it follow through the failure terminal, and it will be going to return to the error.q. Okay, so in this way we have seen how can we use the filter node to filter the input message based on the logic whatever we written into the filter node. Okay, so with the help of filter node we can, with the help of filter node we can apply some filter. So we have seen with the help of filter node we can filter the input message based on the ESQL expression whatever we written, and according to that we can send to the different downstream system with the help of return true, return false, return unknown, and in case of some failure happen it will be going to failure terminal. Okay, so that's all about the filter node. Okay, let's, before closing this session, let's go through the topic. What some I have written some points, so let's go through the point. Okay, so it is used to route the message through the appropriate output terminal, true, false, or non-true, based on the ESQL logic we have written. So whatever the ESQL logic we have written under the filter node, according to that we it is used to navigate the message into different terminal, return true, return false, and the unknown terminal. Okay, further, you know that this there is no compute mode available under the filter node, so it there will be no compute mode, no local environment tree, no output tree, no input root. Okay, so we, there is no concept of input root, there is no concept of output root, there is no concept of local environment tree. Okay, so with the help of filter node we cannot do the any type of transform, we can just transfer the message whatever the input message to output. Okay, so same thing it is in incoming message is not modified, we cannot modify the input message what is coming from the input MQ input. Okay, we can just only pass through the message to different downstream. Okay, further, in filter node, instead of input root dot explainc, we use the root dot explainc to fetch the input message. Okay, in case of, in case of these terminals are not connected and we are navigating the message to different terminals, so message is going to, my message is going to lost. Okay, so same thing, it is, the message can be lost if the message is propagated through the unwired terminal. Okay, if the return result evaluates unknown, the message will propagate through unknown terminal. If the error occur, the node is running, the message is propagated out through the failure terminal, and if it is wired, otherwise it will default error handling take place. Okay, so if you have connected this, then it will happen, it will follow through this failure, but if in case you are not connected, it will it will follow through this cache terminal. Okay, so that's the thing it is saying. Okay, so that's all about the filter node in the IBM ACE. In next class we are going to learn the new other nodes. Okay, so thank you all.